Hello from California. It's 10 o'clock on a Thursday. That means it's time for a Google SAS webinar. And we will get started in about 2 minutes, 2.5 minutes. We give folks a little while to come join us live on the stream, get settled in. So we're going to play about 2.5 minutes of music and then we'll get started. If you're watching this on the replay, you can just fast forward 2.5 minutes and we'll get started then. Hi there, welcome to today's session. I'm Jonathan Westerling, Manager of Special Programs for Google SAS. And one of the thorny issues that revolves around CBRS is interference. Interference can humble your network and make it virtually unusable. But the SAS can help you here because the SAS knows the complete environment, right? It knows all of the devices on all of the channels, and Google wants to help you by letting you use our SAS. Use the SAS to leverage the computing power and the knowledge in the SAS to help you navigate your way through these thorny interference issues. And we can do that, and we've proven that we can do that. We've helped many customers do it. So if you're watching this webinar because you need help with interference, or you're watching it on the replay because you're looking for more resources, this is a great webinar for you today. Now, I want to set your expectations. This is a deep dive into the world of interference. There are some other videos on our YouTube channel that talk in a more general fashion about interference and channels and how to pick the best quality channels. So you can check our YouTube channel for those if you want some of our past webinars. Today is a real in-depth look at our interference resolution tools and how they work and how to use them. So let's take a look at the agenda and what we're going to be covering here today. The first thing is utilizing the CBRS spectrum. What does an efficient use of the spectrum look like, and how does that work when it's functioning properly? The next thing is the tools that Google has available to customers today for interference mitigation. Now, one of the tools you have to ask our support department for access. We'll tell you how to do that. We'll tell you which tool that is. But in general, all of these tools available to you today, and if you just ask for it, you'll get access to that other tool as well. So we'll look at what those three tools are: the channel quality, the channel mask, and the frequency plans. And we'll talk about optimizing cohorts. If you don't know what a cohort is, don't worry, stay tuned. We'll tell you how that figures into things, the concept of a cohort. We'll also look at the best practices for using these tools in your network, letting Google how do you actually let Google solve your channel selection problems? How does that work on a day-to-day basis? And last but not least, we'll give you a sneak peek into a program we're spearheading in conjunction with other SAS operators, and what that could mean for interference in the months ahead. So to do all this, we have a special guest. Before we get to our special guest, I want to remind you that we are live here on usually the third Thursday of the month. This happens to be the fourth Thursday of the month. And you can put this on your calendar and join us live and ask questions live. For those of you watching live, you can ask those questions. The best way to do that is via the chat feature on YouTube. If you've never used chat on YouTube, the first time you type something in, it'll ask you to create a channel. Don't worry, it's just asking you for a name. You type in your name, and then you'll be able to chat and ask a question about interference today. Please also remember there's a slight delay, up to 30 seconds in the broadcast, so we won't see your question right away. But we will try to address any questions that come up on the chat. I'm watching that here on my screen as well. To take us into the world of interference, I'd like to welcome back to Google SAS webinar series Martin Jensen. Martin is one of the consultants who helps us tackle interference issues on a daily basis. So I'm going to transition the slides over to Martin's screen, which sometimes means a little glitch in the audio or the stream. So apologies for that. But here we are. There's Martin. You're on our screen, Martin. I'm going to let you take over and take us through this thorny issue, and I'll be in the background here in case anyone has any questions or if you need any. So over to you, sir.
Excellent. Thank you, Jonathan. Yeah, what we're going to cover today is interference, and one of the many reasons we need to cover interference and why it's becoming more important is because the entire CBRS spectrum is getting more and more utilized, which is a good thing. But at the same time, we got to make sure that it is a shared spectrum, and interference is something that is happening in a congested areas. And also, what is interesting about this type of interference, it's interference between different operators. So it's not just your own interference, but also interference with other operators in your vicinity or in your serving area. Obviously, very important, and Google has insight into all CBSDs deployed in the CBRS universe. And we need to utilize, and we want to utilize that to our greatest benefit to help you mitigate as much as possible the interference. And what we're going to cover today here is sort of the resolution flow, as Jonathan mentioned, to the tools that we're using, the tools that we are offering to you to use to help you with this journey of minimizing interference in your serving area. And again, so just to highlight, the reason we're here today is maximizing the CBRS spectrum. Effectively, what this means is providing or giving more capacity into the available spectrum, utilizing tools and features to make most and the best use of the available CBRS spectrum. 15 channels of 10 each is a lot of spectrum, but there's also a lot of usage and a lot of interest. Every single day we see more and more CBSDs added to the CBRS universe, as we call it. And it is more and more important that we look at interference management solutions, how to mitigate potential interference that is in your serving area, and how we can explain how we can help you with tools that we offer to help you with mitigation of that interference. Just a little bit of an appetizer for what's going on behind the scene. This is a very busy chart with a lot of different colors, but this is effectively what is happening behind the scenes. Google leverages the Google Cloud Compute to provide those and calculate those propagation for every single CBSDs, and it's effectively like a big puzzle that we're trying to put together. How can you move channels around to different CBSDs to minimize, hopefully even eliminate interference in your serving area by shifting channels back and forth within the current site configuration that exists in your serving area for your own CBSDs and for everybody else that serves that area. So this is kind of what's going on behind the scene with a big shuffling of channels back and forth to minimize the interference that might be in your serving area. We're going to jump straight into the mitigation workflow, and there's kind of 4 distinct processes. But it's also important to understand with this, interference is not an interference mitigation is not a one-time effort. It is an ongoing effort. As I mentioned early on, the CBRS landscape is continuously evolving. It's expanding all the time. It's changing, and the way to manage interference, it's an ongoing process. But these are the 4 distinct and unique and interlinked processes and phases that you need to do to help mitigate the interference in your network. And we're going to touch all of them in greater detail in the next couple of slides. But these are the 4 ones. There's one that is configuring your network to instruct the SAS about how you want to utilize the frequencies, how to utilize the frequencies most effectively, what you want your network to do, because the SAS doesn't always know the exact intent of your frequency use in your network. So there are ways that you can configure that with what we call frequency management groups. You might have heard terms such as ICG and CCG. That's also defined in the standards. But that is effectively how we utilize those specific parameters to instruct the SAS and to inform the SAS of here's the intent of this specific configuration for your specific CBSD. So it's important that this goes in as part of the process. Always good input always leads to good output. So it's very important to get this input correctly. The other one is assessing the channel quality. In the portal directly, in the SAS portal directly, there is a tool and a feature where you can assess the channel quality, both of the channel that you're on currently, but also on the other channels that are in that you can utilize for that specific CBSD. You can see individual quality, you can see the power that can be offered for each of these channels. And we'll show you that in the subsequent slide of how you can do that. Now, if the change of a channel is not adequately solving your interference problem, if you can see, you can change channels, but it's not sufficiently to serve that bandwidth and that capacity for your end customers, you need to look at a different approach, which is conduct a larger change, which we call an optimized frequency plan. And that's where that previous puzzle piece we showed came into the picture. And there's a couple of ways that can be done. We're calling it a frequency plan, and these cohorts that we'll go into in detail later on that will help you plan the execution of these frequency plan. Then the last one is the channel mask that we'll go into. You have the way for CBSD or for your SAS to guide your CBSD to ask for the correct channels. Remember, the flow is always the CBSDs in your network is the one that requests the channels. It's the one that conducts the spectral inquiry, and the SAS is there to guide those CBSD to pick the right channels that's right for them to cause the least amount of interference. And this is where this channel mask comes into the picture that we're going to review at this. We created this little workflow hopefully to help guide our customers in how to utilize these different features, when to go from one step to the other one, and then this whole cycle of redoing these interference mitigation strategies over and over again as your network expands. So the first one is to check if there's clean channels. Obviously, if you're having interference on a certain site and you do not have to go in and do a complete frequency retune of your network, the easiest and the quickest way is to look at, do you have other available channels in the vicinity of that CBSD where you have measured interference? And you do that directly in the SAS portal by searching, are there any clean and available channels? And if that is the case, you can use the channel mask feature to direct your CBSD to utilize the frequencies that you want it to go onto. The channel mask feature, as well as the cohort feature, is opt-in. I want to stress that early on. You won't necessarily see that in the portal at the moment, but just by sending an email to Google SAS support, we will be able to turn those features for you, so you can use those in your network. So the first thing is, do you have a clean channel? If the answer is yes, you can retune your network or make sure the CBSD starts to use these new channels that you wish your CBSD to move on to, and you do that with the channel masking feature that we'll review shortly. Now, this may not be sufficient for your CBSD, and you might be able to reduce or improve your interference level, or reduce interference by choosing different channels, but that might not be sufficient for you to serve your customers. And in that case, we need to look at how can you shuffle channels around to get an even better interference level in your network, not just for your current CBSD, but for everything around you. And that's where it's important for us to understand what is your intent with your frequency reuse, where are your CPEs connected, and this is where this frequency management group optimization comes into the picture. And this is where, if you need to update it, I'll show you in the portal where you can set those parameters, and also what they mean exactly. We have those terms, ICG and CCG. We will show you exactly what they mean, and hopefully with some pictures that will hopefully make the concepts a little easier. Now, if there's no changes, or after you have made those changes to tell the SAS about, this is my intent with my frequency reuse, and this is how all my CPs are connected to their current base stations. If you're satisfied with the current selection, just sit and wait, and the Google Cloud engine will come up and calculate a frequency plan that you can see in the SAS portal. So that's where you see from the yellow box going into the green one, you can directly in the portal see the suggested channels for your use for your CBSD, as well as what it's currently set to. You can see that, and of course, you know your network better than the SAS. You need to look at it and see, does that make sense for your network? Or do I have to go in? And in the case in the triangle next diamond boxes, if that is an acceptable plan, you can again go in and use sort of the next phase of the channel mask, which is called a optimized cohort. This is a scaled version of the channel mask. Channel mask is done on a single CBSD, and the optimized cohort is done on a group of CBSDs for changing a frequency plan across an area. Again, we're going to go into that in more detail later on. But in the case the frequency plan does not look acceptable, or you think you can tweak some more on your input parameters, you can go and then optimize those frequency management group, and the SAS will rerun that frequency plan on a regular basis. And after you've done that a couple of times, if it's still not sufficiently, the interference level is not sufficiently improved in your network based on that plan, again, these are a finite number of channels. We need to look at potentially making some changes to the network, moving base stations closer to your CPEs, changing downtilt, and so on and so forth. So there is a finite number of channels. So there is we can help mitigate interference. We can minimize interference, but in some cases we cannot completely eliminate it, and that's why other techniques needs to be applied, which is the last box, and of assessing potential network changes in your network. But this is sort of the decision tree based on the interference workflow that we recommend. Touching on the first one, the channel quality. Channel quality is the one that specifies the quality of the different channels calculated for your specific CBSD with the installation parameters given to the SAS. Channel quality consists of two factors: the current interference level that is seen on that particular channel based on prediction, as well as the amount of power that CBSD is allowed to utilize in that channel. What you see on the right-hand side with channel quality, that is an example of channel quality for a specific CBSD in your network. You see this directly in the portal. For example, if you're transmitting on the middle channels, channel 7 and 8, you can see, well, this is not the best channel quality I have for my CBSD. I might just want to utilize channel 1 and 2, that is a higher quality channel for that specific CBSD. The other thing about this channel quality is also what's represented in the spectrum inquiry. Once the CBSD is powered on, the first thing it will do is to run a spectrum inquiry that will will ask the SAS for what is the channels available, what power can I utilize for that specific CBSD. The Google SAS will respond in the spectrum inquiry with not just the available power, but it will also rank the channels in the spectrum inquiry response based on the quality available for that specific channel. So you'll rank the channels based on channel quality, not just the power. So this is a very important tool that is easy to use. You can quickly see it in the portal, and you should use that in case you have high interference. You can very quickly see, does it make sense for you just to run a quick change to your network to mitigate the potential interference that's there for your current CBSD. The next one is, let's say you are not satisfied with the channel quality that you can utilize in that for that current CBSD. So the two parameters that's important for you to configure to help tell the SAS, I can actually reuse my channels in a little bit better fashion to free up some channels for my CBSD. This is important because the SAS needs to understand and have that understanding of what is your intent with your frequency plans in your network and what can you do and what can you not do. The SAS just only has the information about what's the installed, how is it installed, and the current channels that it's using, and what are the other channels available. But you might have some insight that you can provide to the SAS to help create a better frequency plans. And that's where these frequency management group comes into picture. And there's specifically those two parameters. You might have heard the term CCG, and you might have heard the term same frequency. And it's the same thing for the interference, the ICG, the frequency reuse. Those are common terms used in the CBRS standards. But effectively, the definition of it is relatively straightforward. The frequency reuse, the ICG, as we also call it, is a way that your CBSD can reuse spectrum in a certain area. If you look at the picture on the left-hand side, this is a instruction to the Google SAS that specifies the green channels, ICG2, I can reuse them in a back-to-back fashion on my base station. So, and not only can you reuse that same frequency back-to-back on the bottom base station, north and south direction, but I'm also willing to reuse that frequency in back-to-back fashion on my east and west sector on the base station that is depicted on north, similar to the blue channels. And this is the way you can tell the CBSD, I can actually reuse my channels in a certain fashion that will help the SAS better plan for those specific frequency and make more frequencies available in your network to utilize so that you can reduce interference. The other important parameter as part of the frequency management group is to let the SAS know these specific CPEs belongs and needs to be connected to that specific base station sector. That is the illustration we have on the right-hand side that shows all the blue CPE belongs to the blue sector on the left-hand side, and likewise for the green. That is an important parameter that the SAS utilizes to help understand how far does the signal need to go in order to create those optimized frequency assignments to your CPE. So those are very, very important parameters. The more accurate those gets uploaded to the SAS portal, the better output can be provided at the other end in the frequency plan. The next step is once all these parameters are set, what you see here is an example of what you will see in the SAS portal. There's additional columns that you can activate and see, where you can see the current grant for all your CBSDs. In this case, we colored them in blue. So you can see what they're currently set to. In this case, we're using channel 2 and 3. But with all the input that you've given to the SAS can say, well, not only can you, by changing your channels, you can also get additional channels if you change your channels to these specific channels. On the right-hand side, in the green, you see the frequency, proposed frequency plan. The proposed frequency plan not only tells you where to move your channels, but also tells you you actually have more channels to to utilize that can you can basically expand your channel use by changing different channels based on the interference level in that area. So this is a good way for you to see this is what you can implement and this is what extra you can get. On the last column, that is the new term we call the cohort. Cohort is important for two reasons. Cohort, you might have a network that has 100 CBSDs. And then you might want to say, well, how am I going to change 100 CBSD in a single maintenance window, which is a lot to do and a lot of things can go wrong. What is important also is in many cases, when you change the frequency on one CBSD, it will have a ripple effect for an adjacent CBSD that might be using the same frequency that you're changing to. So in other words, what are all these different CBSDs? How are they linked together? So if I make one change in one CBSD, will it affect multiple other ones? And which ones are those? Which one do I need to change in a cluster, if you will? And effectively, a cohort is a clustering of sites that I can change those. If I change one of them, I have to change everything else in that same cohort. That is what a cohort means, and we'll show you some additional slides later on that explains that concept. But this is the concept behind frequency planning. A way to assess and look at the frequency plan based on the input that you provided to the SAS. And then the cohort, again, as I mentioned, this is the way for the SAS to say, I can see all of these specific CBSDs are interconnected or are linked so that you can make a plan for implementing a mass scale frequency retune that will help you with your interference mitigation in your area. In this case, the yellow one can be treated as a single cohort. If you change one of them, the other one should be changed at the same time, but you don't have to change all of the CBSDs in blue. So that is the definition around a cohort to help you better manage and control and stage those frequency plans that you are thinking of introducing. Or you might want to say, I'm okay with interference in my cohort number one on the yellow cohort, but I do need to change my frequency utilization in the blue cohort. So I can just break it up into different phases, or I can decide just to make the changes in certain areas of the network. And again, the SAS is the one that creates those cohorts based on the propagation that we can determine from the installed data. Now, the last one is the channel mask implementation. This is, again, also an opt-in that you can sign up for. Think of channel mask as a way for the SAS to help guide the CBSD to ask for the correct channel. You set up the channel mask to specify these are the channels that you should use. Here are your active grants. If you look at the left-hand side, these are the active grants. This is the spectrum availability. And then you set your channels that you want to utilize. For example, in this case, you might want to tell the CBSD, do not ask for channel 1 through 5. Those do not have good channel quality. Focus on channel 6 through 9, for example. So that's the way you set it. Now, once the channel mask has been set, and you see there's two ones. There's select channels. If you look at the bottom left, there's two options. Select channels. Select channels is if you just want to implement this channel mask on a single CBSD. Then you click the select channels, and a pop-up screen will show up like in the window to the right, and then you pick the channels that you want it to be able to utilize. The other button is the optimized cohort. And now, obviously, if you are going to change 30 to 40 CBSD in a maintenance window, that is a lot of things to go through individually. This is where this optimized cohort comes in. It works the same way, it utilizes the channel mask function, but this is basically implementing it across the entire cohort with the channel frequency plan that is recommended by the SAS. So this is how you will see that in the SAS portal. Now, just a little bit about how it is implemented. So the SAS guides the specific CBSDs onto better channels. That is effectively the purpose of the channel mask. And it will basically means that if you have set some channels to not to be used, it means that if you are running a spectrum inquiry, those channels will not show up in the spectrum inquiry response. And also, should the CBSD, which is, we haven't seen any that does this, but should they ask for a channel amongst the ones that you have deselected, then that channel will not be granted. Now, once you have set this channel mask, what happens is it stays in the SAS portal, but it's not going to be implemented just until before the next CPAS. What happens just before the CPAS is that the grant will be terminated, the CPAS will run, and then the CBSD will run a spectrum inquiry to find out which channel is available. Of course, the spectrum inquiry will return a pattern according to the channel mask that you set in the SAS portal, and that will basically direct and steer those CBSD to pick the channels that are available in the channel mask. And you have the option to define as large or as little a channel mask as possible, as you define for your network, just to make sure you steer it exactly to where you want. Now, just a note, just check with your vendor that you're using to ensure that there is compatibility with this channel mask. Some CBSD vendors do have some sort of a channel mask function either directly in their CBSD or in their domain proxy, and it's important that we those two channel mask of the SAS, and there might be some equivalent channel mask function in your CBSD, and make sure that they are not conflicting. So check with your vendor to ensure that there is CBSD compatibility, and make sure that there will not be a conflict between channel mask set on your domain proxy and in the SAS portal. One thing to note too, again, CBRS is always evolving, it's changing, new things are being added, and it is an evolving process. The Google SAS utilizes the Google Cloud Compute to create these optimized frequency plan on an ongoing basis. So it is an option to let the Google SAS help you on a daily basis to create frequency plans, to update your frequencies in your network to make sure you always have the cleanest spectrum possible for your install base. Now, just a couple of slides here around what we have seen sometimes. There are some cases where areas are very congested. We have some cases, and this is like what can you do if you are running out of, if even after a frequency retune, that your interference levels are still not sufficiently good enough to carry that amount of subscribers or that service level that you want. So that's when you go into that. There are some options that you need to consider in these cases where you might need to change your actual infrastructure. A case that we see at times is where you have CBSD that's broadcasting very far away from or your CPE is connected to your base station very far away from your base station. And in that case, the operator 1 has a cluster of sites, and you see the operator 2 in purple has other sites that are close by or nearby, and those might be conflicting with each other, creating a lot of interference that you might not be able to circumvent by changing frequency channels. In this case, there is no other option than consider moving some of those base station CBSDs closer to where you're serving your customers. The customer clusters might be the ones that are listed in a red circle there with all the CPEs pointing towards the center base station in red. So this is just one deployment practice that we see being performed in case you have interference that can't be mitigated by changing frequency plans. The other concept that we see oftentimes is when you're utilizing base station CBSDs high on towers, that is prone to be able to get a lot of uplink interference from nearby CBSDs, and might not be your own, might be somebody else transmitting in the area. And in that case, it's oftentimes good practice to lower your antennas on the tower just to help you minimize the uplink interference that you might see from adjacent CBSDs. And then the last one is similar to what we showed on ICGs. This is a way to reuse spectrum within the same site. In this site to the left, you're utilizing 80 megahertz of spectrum, which some of that spectrum might be able to be reused by an adjacent base station sector. And in that case, many ways to get more spectrum is to reuse the existing spectrum on your tower better. In this case, if it is possible, you can perform a back-to-back reuse pattern with the blue frequencies transmitting east and west, and the green frequencies transmitting north and south, and that will basically free up another 40 megahertz of spectrum that you can reuse somewhere else. So that's another technique that you can use if you are running out of spectrum and if you cannot reduce your interference to a sustainable level. Now, the last one is obviously we're working with other SASs too, and it is a joint solution. We can't work on this in isolation, and rest assured that we are working with all the other SAS providers to ensure that some of these concepts that we have here, some of the definitions around our interference coordination mechanisms are identical, so that when we exchange information, that kind of information is exchanged and there are made plans on the other SASs to conduct exactly the same type of interference, and they understand our interference mechanisms and the tools that we're using, so that everybody in the area, including the ones on other SASs, are aware of what we're doing, and we can optimize those inter-SAS communication. The other way we're working this to make sure that we are coordinating correctly with the other SASs is making sure that all of these principles are being inserted into the CBRS standards. And also that not only with the standards, but also with all the vendors, make sure that the protocols are used to exchange that information correctly, because good input creates good output always. And then the last one is we are utilizing the Google Cloud Compute for some of these algorithms. They are very compute intensive, and that is one of the great benefits of our solution, that we can utilize all the compute we have in the Google Cloud to create those optimized frequency plans. And that was the last slide I had. Jonathan, back to you.
All right. Thank you, Martin, for taking us through the world of interference resolution. I will put the Q&A slide up for just a moment. We do have some questions in the chat, so I will run through those. If you have additional questions, now is the time to pop them into the chat, and we can clarify any of the topics that were covered during Martin's presentation here. So I'll go back to your screen here, Martin, so that we can see if you want to point out something in the presentation. But in the meantime, I'll read through these questions, and we can tackle them because I think there's some good stuff here that helps us reiterate some of the points that you were making in your deck. The first, these are from Kevin, who thank you, Kevin, for joining us and for asking your questions. The first question: will GAA coexistence be available in Google SAS? And my understanding is that all the things you talked about today are actually for GAA, right? You don't have to have PALs to be able to use these interference resolutions, right?
That's a good question, Kevin. Actually, very good question, and I probably should have mentioned that. Yeah, it is definitely for GAA. GAA, obviously, that's the one that is mostly utilized for sharing spectrum, and this is exactly for your GAA channels. Utilize this as much as you can for your GAA channels, because we can see what else is being utilized out there on the GAA channels as well as PAL channels. But this is a tool not just for PAL channels, but this is for PAL and for GAA channels.
Great. And the next question touches on something that I think we covered in the presentation, but great to reiterate because it is something that can be a little bit confusing. Kevin asked, can multiple CBSDs on the same tower or pole be assigned the same grant/block so that 3 or 4 CBSDs can act as an omni? This is the ICG, right? This is exactly how we would use an ICG.
Yeah, that's right. In that case, so you're deploying a reuse of one, which is also possible. Some vendors do support a reuse of one. That means that you're utilizing the same frequency in either adjacent, even in overlapping CBSDs on a base station site. So yeah, you can use that. And in that case, the ICG basically specifies, in essence, that's the frequency that you want to use. So if you have a 4-sector site and you want to utilize the same frequency in all direction, that means that what you have to feed into the SAS portal is that you want to use the same ICG in all sectors on that specific base station. And that is super important for the SAS to know, because the SAS looks, and even if you have overlapping antenna patterns on that, some base station can actually mitigate utilizing the same frequency using PCI codes on your base station, and you can reuse the same frequency across all of your sectors. And in that case, what is very important for the SAS to know that this is the intent, that you have to save channels that you reuse somewhere else. In that case, you have to specify utilizing the same ICG or the same channels, basically, on all sectors for that particular base station. And again, if you don't put that in, the SAS will try and give you different frequencies on every single sector. And that way, obviously, the SAS will not know that this is your intent was to reuse that frequency on all sectors in your base station. So very good question.
Yeah, so if you don't put in the ICG information, the SAS will try to make those sectors independent. If you put in the ICG, then you can do that omni configuration that Kevin was talking about.
Yeah.
Great. Next question, is there a listing of CBSDs or domain proxies and the expected setup procedures for each device? That's an interesting ask. The SAS obviously has to work with all the different CBSDs and DPs out there, but it's my understanding is that it's sort of up to each one of those vendors to provide the setup procedures. Martin, do you know of any other resources that Kevin could use in terms of looking at all the devices out there?
Yeah, it's again a good question, and most CBSD vendors test up against both our test SAS to make sure that there is full compatibility between even these new features that we're introducing and the way they interact. Unfortunately, I don't know of any sort of list of vendors that has tested that is official against these different features and how they support and how it's implemented on the CBSD side. But I guess we can take an action to see if there is something, or maybe if we can create something that we can post on our SAS support side.
Great suggestion, Kevin. Thanks very much. I'm going to skip over the next question and go to the last one from Kevin. If anyone else watching has an additional question, go ahead and pop it into the chat there on YouTube before we wrap things up here shortly. This is your last call for that. Got two more questions from Kevin. I'll pop to the last one, which is related to interference, and then the one before that, which isn't. Kevin asks, is there a way to predict what the protection area of my CBSD's grant would be in order to fully understand how tightly spaced the distance the same frequency reuse would be? And this is an interesting, the concept of protection here, I think, is one where we have to be careful, because if you're GAA, there is no protection area, as I understand it. Anyone can come in and use those frequencies if they force the device to do so. So I guess there's sort of two ways to answer this question. The first is there a way to predict the protection area of CBSDs for GAA? But then also, if you do have protection if you bought a PAL, right? If you won something in the PAL auction, then you do have a protection area, and we do show that in the SAS as the PAL protection area. But Martin, I'll throw it over to you in case you have any other things to talk about in terms of the ways to predict the protection area of the CBSDs. Obviously, we also have the network planner, which can show you the propagation, and all the SAS customers get that as well.
Yeah, I think you covered most of it, Jonathan. Yeah, you're correct, and it's important to understand that the GA8 channel does not have a protection area or a zone, if you will. That it is a shared spectrum, and everybody that wishes to use the GA spectrum is welcome to do so. And that's why some of those concepts of making sure that your transmitter is close to your base station becomes very important. If the question is related to the PPA zone for PAL, there is a way to look at that in the SAS portal. I think in one of the previous seminars we showed the protection area for a PPA, the way to show that in the SAS portal. Maybe you can make a reference to that. If that was a question that was related to PALs, we can post a link to that previous presentation. But it is possible to see those protection zones in the SAS for PALs. But remember, there is no protection zone for GA. spectrum.
Exactly. Yeah, when PALS launched nationwide, we did a full SAS webinar on the concept of PALS and how to use PALS if you're a PAL operator, and how to deal with what that meant if you were a GA operator who was working in an area where PALS had been issued. So that is one of the webinars available on our YouTube channel, the Google SAS YouTube channel. The last question that Kevin asks is not related to interference, but I happen to know the answer. Are there any projects which allow SDR, software-defined radios, to use CBRS within Part 96 SAS connections? And I'm not aware of any, because it's an important point for anyone watching this who is interested in the CBRS space. To use Part 96 and to have a device connect to the SAS, it does have to be certified by the FCC. In order to transmit legally on the band. They test the devices to make sure that they're going to adhere to all the specifications. That's what a government agency does. And I'm not aware of any SDRs that are planning on becoming compliant with Part 96, but maybe that's a great business opportunity for you, Kevin, or somebody else watching. So that's that. Not seeing other questions. I will thank you, Martin, very much for joining us here on the SAS webinar today. It was great to have you along again, and thanks for all the work you did to put this together and help us understand interference.
Thank you much.
Cool. I'll switch back to the primary here, and we'll bring up the closeout screen. And thank everybody for watching. If you are, as I said, we've got a whole bunch of webinars on our YouTube channel. Please subscribe to our channel. We're now up to over 300 subscribers on our YouTube channel. We have hundreds and hundreds of hours that people watch these videos all month long. So if you can't join us live, you can replay all of these on demand from our Google SAS YouTube channel. So please encourage you to subscribe. You also get alerted to when we go live if you're subscribed to our channel. So there's another reason there to do that. And it's all completely free and something that we provide to you as a potential SAS customer or one of our customers. If you are a SAS customer, you can always email us for tech support. SAS-support@google.com is how you reach our support department and find out more about these features. You can also search our help center at support.google.com, where we have complete documentation about all of the SAS features that we have launched and how the SAS and the CBRS works, as well as if you're a vendor, a manufacturer, how to run through the test suite on our test SAS as well. It's all there and available to you on our sites. So thank you, everybody, for watching. Appreciate your tuning in, and we'll look for you next month for another hot topic here in terms of SAS, CBRS. Thanks for watching. Thanks for subscribing, and we'll see you next time. Thank you, everybody.